Hello friends, this is the proof video that we're going to use for all the proofs that we saw from section 2.6. So we already learned about the congruent supplements, congruent complements, and the right angle congruence theorems. Now we're just going to try these proofs that we have in this section and see how we do, probably using these new theorems that we just learned. So if you tried these already on your own, congratulations, good job. I hope you did okay on them, and we're going to check them right now. So I'm going to call this proof here number 1, and we're going to try this out. But again, just to talk through it with you to see how you're doing. This one says, given the angle 2 and angle 3 are supplementary, and you know what that means, what do they add up to? We want to show, therefore, that angle 1 is congruent to angle 3. We want to show that. We don't know that, but we want to show that and prove that using hopefully some of these new theorems and everything that we know. All right, let's see how we do. I'm going to write it down here on the bottom of the screen here, friends. I'm going to start my 2-column proof. Top left is always statements. And the top right column is always the reasons, the weapons as we call them. All right. Step 1 is always easiest, right? What's always step 1 is the given. So let's copy down the given. We have angle 2 and angle 3 are supplementary. And again, the reason, just given. Easy. Okay. Now we want to show that 1 and 3 are congruent. So I have no idea where to go. So I'm going to go back to what we talked about last time and just talk about squeezing the juice out of the givens. What does it mean for 2 and 3 to be supplementary? It means they add up to 180 degrees. So why don't we write that down? I don't know if it's going to help, but at least it's something. So I'm going to say the measure of angle 2 plus the measure of angle 3 add up to 180. Okay, that's cool. Reason? Why can we say that? Well, it's because they're supplementary, right? Well, there's that duh reason. Well, duh, they're supplementary. So duh means it's a definition. This is the definition of supplementary. They add up to 180. Okay, very good. Well, let's see, what else could we do? Anything else I can see in the picture? I'm looking here and I see that angle 3 and angle 4 are vertical angles. So if you remember the vertical angle theorem from last time, a while back actually, that said all vertical angles are congruent, I could say that 3 is congruent to 4, but you notice I don't ever really talk about angle 4 in this entire proof, so I don't know if I need that. I could write it down if I want. It wouldn't hurt and it wouldn't be wrong, but I don't think I'm going to need that here. Let's save that for another idea. But what else do we see in the picture? I see that 1 and 2 are right next to each other, so I think they're supplementary too because they are a linear pair. So why don't we put that? So first of all, what I'm going to say is I'm going to state that they're a linear pair first before I say they're supplementary. So I'll say that according to this picture, angle 1 and angle 2 are a linear pair, LP. How do I know that? Well, I'm looking at the picture like duh. They are a pair of angles that add to a straight line. So it's because of the definition. By definition of a linear pair, angle 1 and angle 2 are a linear pair. But then what did we learn about a linear pair? Remember the LPP, the linear pair postulate? It said that if you are a linear pair, you are supplementary, right? So I'll say that. How about angle 1, angle 2 are supplementary? Reason? By the LPP, the linear pair postulate. Remember that one? That's why it's good to have these flashcards and always remember your theorems and postulates and definitions. So don't forget these old friends. Okay, well, let's go. We got that. I've got angle 2 and angle 3 are supplementary. I got that from step 1. And now I got angle 1 and angle 2 are supplementary. Well, that's weird. Look how angle 2 is in the same place for both steps. So look at this. This is basically the congruent supplements theorem. Look what it says. It says that if two angles, angle 3 and angle 1, if they are supplements to two congruent angles or the same angle, oops, I did the wrong angle, this way. Do you see how angle 3 and angle 1 are both supplementary to the same angle, to angle 2? What can we say about angle 1 and angle 3? Well, by the congruent supplements theorem, they are congruent. Hey, and that's what we're supposed to show. Hey, we're just about done here, friends. I could say, therefore, that angle 1 is congruent to angle 3. Why? By the congruent supplements theorem. Yay! And let me review that with you one more time. We know that angle 1 is supplementary to angle 2. Angle 3 is also supplementary to angle 2. And we just learned in that supplements theorem here that if two angles are supplements of the same angle, so here I'm talking about angle 1 and angle 3 are both supplements to the same angle 2. That's what we just showed. Then these two angles have to be congruent. Yay! Well, what were we supposed to prove? Let's look and see. That 1 is equal to 3, and look what we did. We did it. Now, as I look back over my steps, do you notice that I didn't really need step 2? But I was squeezing the juice out of the given. I wrote it down. It wasn't wrong. It just wasn't necessary. So is it okay to include that in a proof even though it wasn't needed? Sure. There's nothing wrong with adding extra stuff even if you end up don't using it. If it's a wrong step, then that's not good. But if it's a right step and you didn't use it, that's still okay. So really, I guess this theorem could only be 4 steps if you wanted to. But there's a great use of the congruent supplements theorem in our proof. Okay, I'm going to erase that in a second. So if you want to pause the video and copy down all those steps, and I'm going to try proof number 2. Okay, ready? Here we go. So I'm going to erase everything I have here, friends. All right, if you tried proof number 2 already, let's check our steps and see how we did. This one might end up using angle 4 that we talked about before. First of all, let's set up our 2-column proof statements. Reasons. Okay. Again, let's see the given, which we'll put down, but let's look at the proof one more time. Let's see, I want to show that, I'm given that angle 1 is congruent to angle 4, or the measures are equal. So let me mark that right away in my picture. 1 is congruent to 4. Great. We want to show here that angle 4 is supplementary to angle 2. Okay. All right, let's try to figure that out. So again, first step always given. So I'll put angle 1 is congruent to angle 4. If you want to put the measure of angle 1 is equal to measure of angle 4, that's fine too. It means the same thing. Reason, given, always. Okay. Now, again, if I'm not sure where to go, we want to squeeze the juice out of the given. Well, to be honest, there's not much more juice I can squeeze out of 1 congruent to 4. There's not much it. So let's go back to the picture and see if there's anything we could get out of there. Last time in the last proof, we were able to squeeze some juice out of 1 and 2 being supplementary, and that was kind of cool. Well, let's put that again. Who knows? Now remember how we did that. In order to show supplementary, we showed it was a linear pair first. So I'll say that angle 1, angle 2 are a linear pair. And remember from last time, that was by definition. Why are they a linear pair? Because, well, by the definition of linear pair, they're a pair of angles that are adding up to a straight line. And then we said, therefore, angle 1 and angle 2 are supplementary. And that was from the LPP, the linear pair postulate. Okay. So we got so far, so good. Angle 1, angle 2 are supplementary. Great. Let's see, what does that mean? That means that if they're supplementary, they have to add up to something, right? So I'll say the measure of angle 1 plus measure of angle 2 equals 180. Do I need that? I don't know, but I'm just going to put it there anyway. What's our reason? Definition of supplementary, right? Because they're supplementary, I can say they add up to 180. Okay, that's pretty cool. But again, if I'm not sure where to go, I want to show that 4 is supplementary to 2. I know that 1 is supplementary to 2. Ooh, but look at the given. The given is 1 is equal to 4. So what if I sort of brought the 1 equal to 4 and combined that with steps 3 or 4? Oh, so watch what I could do. Check this out. I know that 1 plus 2 is 180. So do you agree that I could say that, therefore, the measure of angle 4 plus 2 equals 180? Look what I just did. It's like I took the angle 1 that was there, and I subbed in angle 4 instead. How could I do that? Because in step 1, they were equal to each other. So what's that called if I just subbed him in? Substitution. So I substituted the fact that angle 1 equals 4, so I substituted 4 in for 1. Well, look what happens now. Look what I just said in step 5. I said that 4 plus 2 is 180. So what do you know about angle 4 and angle 2? That means angle 4 and angle 2, if they add to 180, they are therefore supplementary. Why? Because they add to 180. That's the definition. So by definition of supplementary. What are we supposed to prove? We got it. 4 is supplementary to 2. Yay! We proved it in 2 steps. Is there anything in this that we didn't really need? No, I think we used everything. That probably is a really good proof. A 6-stepper. All right, take a breath and we'll try the last one. Number 3 here. Okay, how's your brain? You doing okay with these proofs? Let's do our last one. Proof 3. We're trying to show in this new picture here that if I know that 1 is equal to 4, so I'll say I'll mark it here, angle 1, mark your pictures, is congruent to angle 4. Can we show that 2 is therefore equal to 3? Now that really makes sense. If you look at these, it looks like that if 1 and 4 are equal, probably 2 and 3 are. But we're going to have to try to figure it out. And maybe we can find some relationship between 1 and 2 and 3 and 4 that might help us. Okay, well, let's make our proof. We'll do it all the way down here on the bottom. I'm going to need a little bit of extra room here. 2-column proof. Statements. Reasons. All right, step 1 is always the given. And what was the given again? That 1 was equal to 4. So I'll put measure of angle 1 equals measure of angle 4. Or you can say angle 1 is congruent to angle 4. Means the same thing. Reason. Given. Done. Okay, now we need to show that 2 is equal to 3. So if I want to try to squeeze the juice out of the given, again, there's not much I can do because they're just congruent. There's no supplementary here that I can squeeze stuff out of. So I'm done with that. So I'm going to go back to the picture here and see what I can find. Any relationships? Well, those green circles are going to be really helpful. What do you know about 1 and 2? And 3 and 4? They're probably going to be supplementary. Why? Because they're a linear pair. So let's do the whole thing we did last time. You getting used to it now? I'm going to say that angle 1 and angle 2 are a linear pair. Why? Look at the picture. They're a pair of angles that add to a straight line. So why? Well, duh. So therefore, it's the definition. Definition of linear pair. Okay, well, can we just say that 3 and 4 are also a linear pair? It would be the same reason, so I'm going to put it under the same step. Angle 3 and angle 4 are also a linear pair. Reason, definition. Okay, that's pretty cool. So now, if they're a linear pair, what did we say by the LPP? We know, therefore, that angle 1 and angle 2 are also supplementary. And while we're at it, why don't we hit 3 and 4 as well? And again, that was from the LPP. The linear pair postulate said if they are a linear pair, like we said in step 2, therefore they must add to 180 or be supplementary. Okay. Well, let's see what we got. We want to show that 2 is equal to 3. So I'm looking here at step 3. I know I want to show that 2 is equal to 3. Now, I could squeeze some juice out of step 3 and talk about the whole idea that they add to 180. I could do that. But I've got some better weapons. Check this out. 2 and 3 need to be congruent, right? That's what we're trying to do. So can you look and see with 1 and 4? What do you know about 1 and 4? What did you learn from the given? You learned that they are equal or congruent, right? Now look, that means that 2 is supplementary to 1 and 3 is supplementary to 4. Remember our congruent supplements theorem? If two angles, angle 2 and angle 3, are supplementary to the same angle or two congruent angles, 1 and 4, then what do you know about 2 and 3 themselves? They're also congruent. Wow, we're going to kill this off in one more step. You ready? So right away I can say that angle 2 is equal to or congruent to angle 3. And again, the reason by the congruent supplements theorem. Okay, that said, again, that because 2 and 3 were supplementary to 1 and 4, and 1 and 4 are congruent, then 2 and 3 are also congruent. Proof destroyed in 4 steps. So as we do more and more proofs here, friends, start to see patterns. start to see the fact that we always start with the given, that a lot of times we want to squeeze the juice out of givens if we can. And if we can't find anything more, we go to the diagrams and try to figure out what we could use. And look at these different weapons: definitions, postulates, theorems, and start looking for those patterns that we seem to use a lot of times, very often in these proofs. All right, so there are the proofs that we learned in section 2.6, folks. We'll see you next time for some more proofing.